Good morning, everybody, and welcome to the first ever Katiev's Fusion Fridays. I guess it's the first for all of us here, so definitely welcome. It's going to be all of our first experience with Fusion Fridays. So go over a little bit of who we are and what we do here. So I'm Nigel Mbayak. I'm noticing a lot of familiar names here in the attendee list from our Autodesk Virtual Academy. So to all of you, welcome back. I guess it's a little bit different. We're doing it on a Friday instead of Thursday morning, so a little bit of change of pace. So definitely glad to see you all here today. Today I'm joined by a couple of people maybe familiar to you if you've watched a couple of AVAs in the past. Brian Monkolbutek. I'm sorry if I butchered your last name. It's really long. And then we've got Alice Alvarez. So he was actually on a presentation yesterday, so might be a familiar face. Looks kind of like Dwayne The Rock Johnson. So both of these gentlemen are Fusion engineers here on our team. They've both focused pretty much strictly within Fusion 360 as a platform. Brian on more of a modeling and general side, whereas Alex is kind of on the side of manufacturing. So things like CAM, 3D printing, general manufacturing techniques using the tool. Alex is your guy. So if you have any questions about anything that we're doing today, let us know in the chat box on your screen, and we'll be more than happy to answer those questions. So just a little bit of a background on why Fusion Fridays, and why not just continue with Autodesk Virtual Academy, for those of you who know what that is. Fusion 360 specifically has warranted a lot of need in terms of webcasts, and we've seen a lot of traction in regards to Fusion webcasts specifically, and we kind of deemed it necessary to generate its own, it's kind of warranted its own series of webcasts, which is why we've started this new series called Fusion Fridays. It's going to be, for now, for the next foreseeable future, it's going to be once a month on the first Friday of every month. So definitely jot that in your calendars. Everyone here is subscribed, so you'll probably receive an email just noting you which session is next, and reminders similar to if you already subscribed to Autodesk Virtual Academy. In a couple of months, we'll kind of reassess that, and if we need to do these once every 2 weeks or even once a week like AVA, we'll be more than happy to do so if there's a need for it. But let's go ahead and get going. So we've got a great show for you today, and I guess we're going to answer the question, what is Fusion 360? Go ahead, Brian.
All right, thank you, Nigel. So my goal today is to make sure that you guys watching are able to answer this question right here. What is Fusion 360? So Fusion 360 is a next generation design tool that has everything you need to go from concept to fabrication. For example, you can create a sketch, turn it into a 3D model, and then send it out to be fabricated, all without leaving the tool. And I encourage you guys to ask questions during this presentation, and then we'll answer it at the end.
Certainly. So just like a quick overview, expect to be here for the next 30 to 40 minutes or so. Don't want to take up too much time of your day, but this is kind of a, surface level kind of understanding what the tool capabilities are and all of the different workspaces you have in Fusion 360, because it's a little more robust than some of your traditional tools.
So everyone has access to Fusion 360. If you have the product design collection, then you already own it. You just need to go and download it. If you're a hobbyist using it for a weekend project, or if you're a student using it for education, it's free for you. And if you are a startup company or a small business, it's also free for you as well. And if you don't know if you qualify for a free version of Fusion 360, let us know and we can answer that for you.
Definitely.
So now we're going to go into Fusion 360. And like I said earlier, Fusion 360 has everything you need in the design process, including computer-aided design, which is one of the crucial components of Fusion. So now we're in the Fusion 360 workspace, and if you're familiar with 3D modeling, you can see that there's a sketch panel here to create 2D sketches. There's a create panel here where you can create your 3D models, modify panel here where you can edit those 3D models, and so forth. So today we're going to be making this chair right here, and I chose this example because I thought it was a good idea to combine both the parametric features or geometric features like the legs, as well as the seat, which are the T-spline, like organically shaped freeform modeling features. So yeah, let's go ahead and create a new design. So I went up to File, New Design, and now to get started, let's go to Create Form, and now it tells us we're in the sculpt environment, so we'll hit OK. And we'll start off with a box. So I go to create box. And the cool thing about Fusion is that once you stop moving your mouse while using a tool, it tells you what you want to do next. So now it's asking for you to select a plane or planar face to create your box. So I'm going to select this plane right here. And now it's asking us for a center point when I don't move my mouse. So the center point of my box. So I'll go ahead and select the origin. And I'll make this box 16 by 16. And now before I hit OK, you can see a preview of the box. But first I want to add some edges to the box so I can edit it later. So I'm going to go to Display Settings and hit Shaded with Visible Edges Only. So now I'm going to increase the complexity of this box by using these tools here. I'm adding more faces. And then with this arrow tool here, I'll decrease the height. And then once I'm happy with my object, I'll hit OK.
And so what does more faces add to the model? What do you get with having more faces versus less, Brian?
Since you have more faces, the box becomes more complex. So you can pull a little bits and pieces of the box rather than pulling like half the box whenever you extrude it.
Right, so you have more precise control.
Correct. Yes. So now we have the place to sit on for the chair, and now we want to have some backrest or create a backrest. So to do so, I'm going to select these back faces right here, and I'm going to hit right-click Edit Form. And if you see here, I'm going to use this arrow tool to pull up a backrest, but it pulls my model apart rather than extruding it. But I would rather have it extrude and not have to pull up these parts because this is where you want to sit. So I'm going to go ahead and hold the Alt key.
Yeah, so in essence, the Alt key just adds material to your surface.
Right. So I'm holding Alt right now and I'm pulling it up. And once you get the height that you desired, then you can hit OK. So now we're getting a general form of the chair. But you don't want to be sitting at a 90-degree angle chair. So you're going to want to angle it backwards. And I did a little research and I found out 15 degrees was a good angle to be sitting at. So I'm going to go ahead and highlight these faces here. Right-click Edit Form once again.
So yes, a chair ergonomics expert, you want to know that.
Yeah, I should start my own business. Okay, so you can rotate this back to -15 degrees, and then you can use this tool here to manually pull back the backrest. And then once you get that, you can hit OK. Alright, so before we exit the sculpt environment, I want to create a little indent here where we sit, so then when you sit down in the chair, you kind of get centered to the middle. So I'll go ahead and hold Control once again and highlight those faces. Right-click Edit Form, and then use this tool, push down 1 inch, and then hit OK. So now once I hide my edges, you can see the shape, the form of the chair. Yeah. So now we'll exit the sculpt environment, and now we'll create the legs for the chair. But before we create the legs, I want to create a plane that lies in the middle of the seat. So then we can create a sketch on that plane and then extrude.
So is this a surface model, Brian, or is it a solid model?
This is a solid model.
Okay.
Yeah. So I'll go ahead and go to Offset Plane. I'll show my origin because I want to offset a plane of the origin. And then I'll offset it 1 inch into my model. Then hit OK. Select the plane that I just created. And now I'll specify the center of my rectangle at the origin, and I'll pull it out to about 12 by 12 inches. And I'm going to use the corners of these rectangles to be the center points of my circles for the legs. So I'll go ahead and create 2-inch circles here. And the way I'm getting to the circle tool is I'm hitting C on the keyboard for the center diameter circle tool. And then I'm hitting 2 for the diameters.
Yeah, so most of the hotkeys that from AutoCAD, they kind of transfer over to Fusion 360.
Yeah, AutoCAD and Inventor, a lot of the hotkeys do translate over into the tool.
Yeah, and as you can see here, as I'm hovering over the corner of the square, the blue little square pops up. That tells me that it's going to snap to that corner, so I don't have to. So I can be sure that the center of my circle will be the corner of this square.
So something like this, where you're generating, extruding certain closed profiles, things like that, creating sweeps and stuff. That's more something that you're probably more familiar with if you're moving from a tool like SolidWorks or Inventor. Whereas some of this more organic modeling is something more familiar for those people who may have come from Rhino or Alias or things like that. Just want to let you know that there are multiple ways to build something. You could very well build that chair back with like parametric modeling. It just obviously going to take a little bit longer.
So now we're going to hide the body for a brief moment. So I could select the circles of this chair. And then I'm going to show the body again so I know which direction I want to extrude in. I'm going to extrude in this direction about, let's say, 16 inches.
So yeah, you could pull that arrow, or you could just type into the box, Brian, if you want to like cover over the distance box.
Yeah, right. We can type it in here as well.
Yeah, if you want to be very specific, like 16.67, that's not something you're going to get with the arrow, but always just plug it in if you have a parametric or if you have a parameter that you need to.
Exactly. Yeah, exactly. And instead of a cover operation, I'm going to do a new body operation, and then click OK. So now we have the shape of the chair and the model designed within a couple minutes. And to get a final set, hit A for appearance. I'm going to click and drag and drop some and there we go. And the cool thing about modeling in Fusion, you can have other team members as well. So to invite other team members, you can go to the data panel at the top left-hand corner of the screen and go to the Peoples tab. And they can insert their email address here. As you can see, there's Alex and Nigel in here. And they have access to editing your model as well. So once I save this model, for example, let me go to the green chair that I have earlier. Once I save the model, then they can see it, they can make changes, and then they can save it, and then I can see this, the newest version of it. And it's that kind of system, the kind of cycle that Fusion is built around. And they can also we can also make comments here in this comments tab. So as you can see here, I requested that the chair, earlier it was red. I requested to myself that to make it green, and now it's green and it's a new version and things like that. Like Fusion organizes all these comments as well.
Yep, so there is version control with Fusion. It's kind of lying on the same backbone as Fusion Team or Fusion Lifecycle, but in regards to like the data management side only. If you have questions about like the data management capabilities of Fusion 360, certainly let us know. It's certainly not as robust as something like a Vault, but it does get the job done depending on what specific things you do need.
Right. And then being able to interact this way in Fusion, you no longer need to send each other email addresses or upload your drawings to Dropbox or your models to Dropbox, because then now you have all the files in Fusion. Like there won't no longer be missing links between assemblies, no longer be lost files, and no longer be saving over each other's files.
A good example with that too, Brian, is like our current senior design project.
Right.
How we have so many parts going into the ball hawk car that we're building. All these parts, they do have different revisions, so they get scattered all over the place because we were using SolidWorks and using Dropbox to save those parts. So those parts just get scattered everywhere, whereas in Fusion 360, those parts just get numbered.
They're all organized. Yeah. So also, yeah, I was talking about the saving files over each other. Like in Fusion, like let's say you have version 6 here, and then you or someone else in the team saves over it as version 7. You still have access to your version 6, and you can. And if you want to keep your version 6, you can go to promote version and make that the most current version or current model that you guys are working on. Or you can open it here and rename it something else.
Right. And so the backbone for all of this is like Amazon Web Services. As most people know, like the cloud is where all these things lie. So these files, if I'm going to make a silly reference here to a great movie, the files are not in the computer. No one gets that? No? Okay, cool. So certainly, yeah, the files don't lie locally. They lie in the cloud, kind of like your cloud storage. If you do need them locally, there is a way to get the files locally to your computer, though. You just don't have like all the versions and stuff.
Yeah. So also, if you let's say you want to send your chair model out to a customer or someone who you don't want to have access to editing your chair, then to do so, you can just right-click and hit Share Public Link. And what this box allows you to do is allows you to copy and paste this link. And by checking this box, they can download it as well, but they can see a 3D viewing model of your link, which I'll show you right now. So if I go to my web browser, I pasted that link into this web browser, and then whoever you sent that link to will be able to see the most updated version of your model here in this 3D viewer. Is that you're able to, one, you don't need any plugins or add-ins to view it. Two, like I said earlier, it was the most updated version of your model. So that means that if you sent your model out 2 months ago to someone and they want to see your progress on it today, then they can just click on that link you sent them 2 months ago because it updates as you update your model.
Yeah, so you can think of it this way, if you know some of the Inventor verbiage. This is associative to the newest version of the model in that sense. So.
Yeah. And then also, since I checked that download box earlier, now the person who has this link is able to download your model in all these different file formats. So if they wanted a step file, but then later they decide they want an SAT file, you don't need to send them a new file. It's all located here.
Yep, and all you need is a web browser. You can even do this on your phone too, so it's really cool.
Yeah. So going back to Fusion, lastly, here's an example. Like if your customer is sending you a SolidWorks assembly and you need to open and you want to open it with Fusion, you can do so by going to the Upload button there, hit Select Files, and then I have this Lego Man SolidWorks assembly that I got from GrabCAD.com, and I'm not going to hit Upload because I already uploaded it here, but you can see that there's an assembly file here, and then if you open up, or once it finishes uploading, it'll appear something like this. And the cool thing about Fusion is that it recognizes the top level component or the top level assembly file, and it puts it at the top here. And then for the rest of it, it recognizes, where it was located, how it was associated with the other components, and it reads it down here. Okay, so now I'm gonna hand it over to Alex so he can show you guys how to create toolpaths with the CAM feature.
Yeah, thank you for that, Brian. All right, so let's say you have the final revision of your part, right? So what would be the next step? For most people, the next step would be manufacturing your part. So whether that be machining it or 3D printing, Fusion 360 gives you all that access without having to leave the page. So let's take a look at this example. This is actually the gearbox, our current design for the gearbox for our senior design project. This part was actually designed in SolidWorks and brought into Fusion 360. So like Brian mentioned earlier, Fusion 360 does give you that capability of importing different file types. So here, typically when you're going to machine this, you would start off with your stock. We set our work coordinate system over here on the top left. And if you look, once you set your work coordinate system, or once you select that setup, you get a little dialog box over here on the right. So here you would just select your operation type, which in our case we're doing milling. Your orientation of the z-axis, like which way is going to be your positive z and your negative z. And then, like I said, Fusion 360 gives you all these capabilities, and it just gives you that visualization when you're hovering over a certain box. So I'll demonstrate that once I jump into Fusion. So what are some common toolpaths that Fusion 360 has? So as you see here, we have some facing operations, we have some outside roughing operations here, we have some finishing operations. So these are much, more or less pretty much the process that we took to get this gearbox done. So let me just jump into Fusion here so we can see the simulation. Okay, so once you have all your toolpaths, you want to make sure that your machine is going to do what you want it to do, right? You want to be sure, have that assurance when you're at the machine. Especially if you're, a self-taught machinist, or if you're just new to machining, you don't want to crash the machine because that's going to be a pretty expensive mistake. So let's just go over to the top and click Simulate. And we see that we get a visualization of the stock. So let me just play the simulation. Fast forward it here a little bit. So we see that all the toolpaths that we created, Fusion 360 is simulating that. Now, when I first started using the CAM capabilities within Fusion, I was a little worried that the simulation wasn't going to, do exactly what I want the machine to do. So I was a little hesitant at first. But being that I actually programmed all the toolpaths and I ran the machine myself, I noticed that the simulation was the machine was doing exactly what the simulation in Fusion was showing. So you can be sure that the simulation within Fusion 360 is exactly what your machine will be doing. Okay, so here, let me just rotate it. So
as long as you put the right tool in the machine.
Correct, yeah, and you set your correct height offset. So if you're familiar with machining, you'll know what the setting your height offsets and selecting your correct work coordinate system. Okay, so once that you have verified that your simulation is correct, you can definitely go ahead and post the G-code. So you would just go over here to the top on post process, and you see that you have different posts. So Fusion 360 comes preloaded with a variety of post processors. You can take a look here, and so some common ones are the Fanuc. You have Haas, Fidel. So you can take a look over it. Now, if you don't see your post process on here, you can contact us and we will help you get that started. So let's say you're ready to go machine. Once you jump into once you post it, you will get something that's similar to this, which is the G code. So I just posted the first operation, which is a facing operation, and you see that Fusion 360 gives you the complete code for that facing operation.
And also the post processors, they're always adding new ones. So if they don't have yours yet, you can request that and they'll make it for you.
Correct.
I remember writing this.
Yeah, back then this was all hand code written. So it was pretty crazy how it was. All right, so with that, I'll hand it back to Brian.
All right, thank you, Alex. All right, so now we'll go over rendering. So it's easy to hop from workspace to workspace. Like right now we're in the CAM workspace. If you want to go to the rendering workspace, you can just go down to here and then just click render. And rendering is useful because you're able to create these high quality images. Like this is an example of the chair I created earlier. And you can create these high quality images to send out to other people. So for example, like he said, Alex said, we're in the Baja Racing Club. And we created this high quality rendering of the car. And with that, we're able to send it out for people. We're able to advertise with it.
Get sponsorships.
And get sponsorships and promote for new club members to join for like the next year as well. So there's a lot of benefits to that, and you could also save it for your own professional documentation.
Certainly, and you can do animations and you can do stills. A lot of times, when you need approval from like a higher up per se, maybe not someone in engineering is like, hey, we picked a color for this thing. What does it look like? Yeah, marketing people predominantly. Does this color look okay, or does all of this look fine, or does it need to be smaller or bigger or whatever? Rendering is certainly a good way to represent that file without actually having to build it.
Yeah. So the next example, let's say that your boss is asking you to test to see if your wall shelf will hold up against like 100 newtons of force or whatever, however much these guys weigh, and you want to show them a way to do that. So to do so, you can go from the modeling workspace in Fusion and go to your simulation workspace. As you can see here, I created a static stress study on this wall shelf that I created in Fusion. And as you can see here on the left, you can see where I applied forces. And I applied 100 newtons of force onto this wall shelf, onto this face. And then I applied fixed points where the holes are, as if I had bolts going in through the wall shelf into the wall. And it shows, Fusion is able to show like different factors of safety and all the different stresses that are being applied to your model. And if you show an animation, it's exaggerating the formation of it, because 100 newtons of force will probably not cause this to the model, but it's giving you a good visualization of what it were to look like. And this is good for design validation, because if it doesn't pass, the safety factor of safety here, you can go back to the model workspace and then create a support bracket or whatever you need to design better, improve the design, and then you can go back to the simulation workspace and then test it again.
Yep, and it'll be updated because that model is associative to the simulation. So if you just add something to the model, when you come back into the assembly, it'll have you update it, and then you can just run the same study all over again with your updated model. So it's not like you have to recreate this study all over again. It's a big deal sometimes. So.
All right. So lastly, there's the here's the drawing of Fusion, and drawings are useful because you're able to send these out to machinists or send them out to get a quote. And here's an example of a rod joint assembly that I got from Autodesk, and you're able to create like a list of materials. For example, here's a two-part assembly, and if I want to show those two parts, I can go to the parts list up here and drop it somewhere in my drawing, and it automatically fills out that table and numbers it for you. So, for example, the connector support brackets number 1, connector bodies number 2, and if I want to specify which one's which in this isometric view of my drawing, I can go to the balloons tool here, and I can specify them like this. So you can see that that's number 1, this black piece is number 2. And so number 1 is the connector support bracket, which is the orange one, as the connector body is the black piece. And also you can hit D for dimension if you want to further dimension your part. There you go. And then as well as hit C to use a center mark, the center mark tool. And if you click on a circular body like this, it'll create center mark tools, or it'll create a center mark for you. Lastly, you can edit the title block here by double clicking on it, and you could update the revision number or create a drawing number for it. Yeah, like I said earlier, you can send these out to machinists, and then they can use the dimensions to create your part. Okay, so now to recap, today we learned that Fusion includes everything you need to go from sketch, 3D model, and fabrication, all without leaving the tool. I hope you guys now have your own answer to the question, what is Fusion 360?
Yeah, and keep in mind, guys, too, that this was just an overview of Fusion 360, but throughout the course of these next upcoming months, we are going to dive into the core of Fusion 360 and more of its capabilities. Like we didn't even touch the surface of what Fusion 360 can do.
Certainly, yeah. So I think we can move on to some questions. There are certainly a couple that have come in. Let me go press button 1 second. Hello, and we, as you can see, we've all switched places except for Brian, I guess. I guess he just ended up in the same place. But we do have a couple of questions. Like I did mention, if you do have any, feel free to type them into the chat box anytime. They're just live right here on my screen. I can see them as they come in, and we'll make sure to address them. It looks like we've got a couple coming through, so certainly good. So first question came in pretty early here from Fernando. Asking, does this software do flat pattern? For example, let's say you want to wrap the chair in or seating areas in leather or something along those lines. It does not at this point. You can't do flat patterns for like a surface model like that. For those of you who are asking the same question, oh, flat pattern, that reminds me of sheet metal. Does Fusion do sheet metal? Actually, that's something that they're working on right now, and it's in the Fusion beta.
Yeah, they have a beta version release.
Yep. So flat patterns and sheet metal are in the beta version of Fusion. They're going to roll that live here pretty soon, I think. And along that same token, Fusion's really open with their progress moving forward in regards to adding new features in the tool. They're very transparent about that. So you can just even look at the Fusion website and kind of look at their path and what they're currently working on, what they plan on working on in the future, and then the timeline of when that's going to kind of get implemented. That's all available to you using the Fusion 360 website. If you just Google that, you'll be able to find it. All right. And so this question came in from Joseph. Is there an option to have made the square that located the legs as reference geometry, so it didn't make you click on each circle to create the rest of it?
Mm-hmm. Yeah, definitely. Yeah, if you click on the rectangle, You are going to get a little dialog box on your right-hand side, or depending on where you have it. But it gives you all the, what you could do, kind of like SolidWorks, where you kind of set the constraints. So you would just set that as a reference geometry, and you would have avoided, clicking that other part of the circle.
Yeah, we didn't want to jump into that. I'm just going to give like a short introduction into this. I think some people might have gotten a little lost if we did like a pattern or something along those lines. But that's something certainly if people want to learn some more sketching techniques and general modeling techniques, that's something we can certainly go over. Tips and tricks how to save a click here, because every click saved is time.
It is.
And, in theory, money. All right, so we've got a question here from Darshan. What's the difference between Inventor and Fusion 360? Which is better? So that's kind of a loaded question. I was kind of expecting to get this one, so I think I can take this one. So Inventor and Fusion 360, two completely different tools. People are like, oh, well, Fusion's like baby Inventor, or Inventor is like Fusion not in the cloud, things like that. They're actually completely different tools. They both have their pros and cons. I don't want to necessarily say one is better than the other, because it really depends on your use case here. Excuse me. Both of the tools have features that the other tool does not have. Specifically, I think that the big one is if you have fairly large assemblies in the multiple thousands of parts, Inventor is probably a little bit better and a little bit more robust in regards to that than Fusion is at this point. Not saying that Fusion will never be able to have an assembly of 25, 30,000 parts, but as it is right now, it's probably not capable of running that pretty smoothly. Fusion has thermal simulation, something Inventor doesn't have. It's really big. But a lot of the tools do carry over to both tools, and Autodesk is kind of developing them both kind of in tandem. So you will see a lot of Inventor tools in Fusion moving forward, a lot of Fusion tools probably making their way into Inventor moving forward. There are two different tools, and the data management of everything is a little bit different, because Fusion kind of relies on that cloud to get your files and stuff, whereas Inventor, you can use something like a local drive, you can use Vault.
And the collaboration of Fusion.
Exactly. Yeah, it's a little bit different. So hopefully that answered your question, kind of going over some of the high-level differences between the two. But Dan, the question, which is better, I really think is it is up to the user and what use case you have. One might be better for you than the other, depending on what you're doing with the tool. All right, another question here from Brian. Is it possible to create an organic solid using Fusion 360 and import that solid into Inventor to use in an assembly living on a desktop hard drive?
Yeah, you can create that, like in that chair I showed you, is an organic solid. So you can send that out to Inventor as like an STL file or a step file.
You can even export it as like an Inventor file.
Or an Inventor file, I forgot.
Which is actually really
There's an option, yeah.
Yeah, so you can actually export it as an Inventor file, which is really cool, because Autodesk, they want to play nice with their own products.
Yeah.
So yeah, Brian, if you want to jump in there really
Go
quick.
back to the that link right here. Where is it?
Yeah,
There's an
Inventor
Inventor file.
2016.
And this is the organic shape that we were talking about.
Exactly. So along the same lines of this, as you see, that's Inventor 2016. One of the big things with Inventor is it's not backwards compatible per se, using like native Inventor files. Something like Fusion is a little bit different. Inventor, you have your big Inventor, SolidWorks, Rhino, all those really big modelers. You have your giant updates every year. So actually expect in here the next couple of weeks maybe hear about an Inventor one. They have their huge update every year. It's kind of a big deal. Your IT guys have to like dedicate an entire weekend to upgrading the entire team for things like Vault, Inventor, AutoCAD, whole suites and stuff. Fusion kind of does that in the background for you. They release smaller updates every 4 to 6 weeks, and they just happen. So, for example, was it March 1st?
March 1st.
So 2 days ago, they released an update. Alex, if you want to share some of the information.
Yeah, so they did some updates to the drawings as well. So now you can do multiple sheets for the drawings. So Brian, if you want to kind of go into that. Yeah, so you just now have the option to do multiple sheets, where instead of before you had to copy and paste the whole drawing sheets, now you just switch over the tab and then just create a whole new drawing sheets.
Exactly. There's a lot of other stuff in regards to what they added. And like I said, you can go to the Fusion 360 website at Autodesk directly and be able to see what they just released or what they're going to be releasing. We'll probably do some updates in regards to these presentations moving forward. So expect to see some of those in these future sessions. Let's see.
Yeah, so in the meantime, so another neat thing about Autodesk too is that they really listen to their customers, right? So for Fusion, for example, they have this forum where people can just go and kind of talk to them about some of the issues that they've been having with the program, or something that they could improve based on user experience. And Autodesk really listens to you. So all these updates that you see, they pretty much try to go ahead and what's the word here, and help or reach out to the customer and kind of see what they need help with, and then release the updates based on what they need help with.
Yeah, they don't shy away from releasing a hotfix for everyone if like a handful of people are having a problem.
Yeah, and they help them out.
Yeah, if you need help reaching out to Autodesk, or you need to reach out to us in regards to helping you fix something in Fusion, definitely do so. The email address was on the screen there if you want to jump there, Brian, real quick.
The email address, yeah.
In the PowerPoint presentation. There you go. Reach out to us at that email or that phone number. We're more than happy to help you out. Let's see here. So Scott, I'll reach out to you in regards to creating the problems that you had in regards to sending it out to your 3D printer. If you need some help with that, I'm sure Alex will be able to jump on with you and help you out. He's kind of the resident 3D printing Fusion guy. So he actually did a webcast on that yesterday. So if you didn't see that, definitely take a look. Certainly. So.
And also, what I was going here to show you guys was when they created a new beta test for anything, you can go here to Preferences under your name and go to Preview, and they like to drop it in here. Like for example, the March update. I think they just added the water jet laser support. Yeah, for that. So if you checkbox those or the new updates, then you'll be able to play around with it and actually use it for your, to see if to see if it works.
It's like applying plugins to another program, and so you'll see those things pop up in your ribbon. I don't know if that's what they're calling it. Probably ribbon. So anyways, let's see. We'll wait a little bit more. I'll give everybody about 30 more seconds to post any more questions that you do have. Just want to let you know we are always looking for feedback. This is our first Fusion Fridays. That's certainly a mouthful. Triple Fs, I guess. So let us know what you want to see in the future. You'll probably get a survey after this in regards to what you want to see. Next month, probably going to be looking into something a little bit more basic, or depending on the survey responses, we might do something a little bit more advanced. So be on the lookout for what's next. We're kind of going to use the responses we get from the viewers to drive what we're going to be showing in the future. So
so be sure to answer that into the chat room, what you want to see for next month.
Yeah, or in the survey, you'll get one after this. So with that, I'll wait a little bit more for a couple more questions. Again, I'd like to thank everyone for being here today. I do recognize a lot of people from AVA, which is our Autodesk Virtual Academy. If that's something you haven't heard of before, maybe this is your first KT webcast that you've been to, you want to see more on maybe Inventor, AutoCAD, data management using Vault, other things like that, let us know. We can get you signed up for that webcast. We do have another weekly webcast in which we kind of switch up the topics every week. But
we're having that Fusion meetup. Nice.
Exactly. Yeah. So thank you for reminding me. So we will be having an in-house Fusion meetup here at the office. Be on the lookout for an email from us about that. I think you guys are going to demonstrate some camming and some Fusion.
We're going to go over Fusion camming on March 15th on Wednesday.
I believe so. It's kind of tentative. We'll figure that all out. But expect to see that email here pretty soon. Alex is going to go over a little more in-depth, not just a little bit more in-depth, but a lot more in-depth into some of the camming features in Fusion 360 and how to get your parts from your 3D model to G-code and sending that to your
visual paths and simulating it.
Exactly. So with that, there's no more questions that came in. If you do have any, go ahead and post those in the survey afterwards, or send us an email here, questions@kativ.com. I'll be more than happy to answer that for you, or any of these two. So with that, I'm Nigel Black, here with Alex Alvarez and Brian Kolpensek.
Yeah.
I got his last name right. Yes, I'm so happy. That's the first time in a while that I've gotten that correct. And we all thank you for being here today. We'll catch you next month. Be here first Friday for Fusion Fridays. Thanks, guys. See y'all later.